Okay, just like with any equation, we want to be able to use what we know about solving equations to be able to apply it to real life situations. So we're going to do that with quadratics, just like we do with linear situations as well. So we've got an object that's projected straight downward with an initial velocity is v, in feet per second, that travels a distance. So the equation is already solved for distance. That s is going to represent our distance. And this whole equation, we can find the distance an object travels if we take the velocity times time plus 16 times time squared. Somebody has already developed this formula for us. So the hard work is actually done for us. We don't need to come up with this formula. It's given to us. We just have to be able to plug in the values that we know into the appropriate spots. T equals time in seconds. Ramon is standing on a balcony 84 feet above the ground, and he throws a penny straight down with an initial velocity of 10 feet per second. So that's going to be important. In approximately how many seconds will it reach the ground? So how many seconds tells me we want to solve for t. Okay, because we're trying to find out how many seconds. T stands for time. S is a distance. V is a velocity. And our t is time. And we're trying to find the time. That's the one we don't know. So our distance at the beginning of this situation is 84 feet because Ramon is 84 feet above the ground. And the initial velocity that he threw the penny with was 10 feet per second. So he gave it a little push. He didn't just let it drop, because if he just let it drop, the initial velocity would be 0. But he put a force behind it at 10 feet per second. We don't know how much time it took to reach the ground, so our variable stays t squared. We've learned several ways for solving quadratics, but in almost nearly every single way that we learned, we had to have it equal to 0. And since we want to know when the penny reaches the ground is 0 feet, so we do want to have this equal to 0 to be able to solve it anyway. Because we want to know, when is it 0? Not when is it 84 feet above the ground, but when is it 0 feet? When has it reached the ground? Also, when we're solving quadratics, we've learned that it's easier to do so when it's in standard form. And this equation is not in standard form. We want our t squared first, and then our t term, and then our constant. So in this problem, A is going to be 16, B is 10, and C is negative 84. Now we've learned several ways that we can solve quadratic equations. We could graph this, and if I had my graphing calculator hooked up to my computer, that is probably the way that I would do it, and I'll share with the class how we could do it that way as well. We've learned factoring, and for some reason I was struggling with factoring over on my paper over here, so I kind of gave up on the factoring. We've learned completing the square, which is not a favorite of mine, and we've learned the quadratic formula, which will work every time. So I'm going to go with the quadratic formula. And in case you forgot it, x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So now it's going to be a matter of me plugging in these values for a, b, and c and doing the math. And hopefully having enough room to get all this in. Opposite of b, so opposite of negative 10, plus or minus the square root of b squared. Well, that's 10 squared minus 4 times a. A is 16. C is negative 84. All over 2 times a. Clean that up here in a little bit. So negative 10 plus or minus 10 squared is 100. 2 times 16 is 32. This middle part I don't know off the top of my head, but I do know that when I do a negative times a negative, I'm going to get a positive. And I will pull up the calculator to do 4 times 16 times 84, and I get 5376. I know that if I add 100 to 5376, I get 5476. So I want to find out what the square root of 5476 is. It's 74. So I'm going to have 10 plus 74 over 32. Oh, I'm sorry, negative 10. And I'm going to have negative 10 minus 64, not 64. I'm starting to think ahead a little bit. Minus 74 all over 32. And what I'm thinking ahead to is right here. Negative 10 plus 74 gives me 64. 64 divided by 32 is 2. So actually here, now that I think about it, it's not x that we're finding. It's t that we're finding, and it's not letting me. It's t that we're finding, because we're solving for time. So t equals. So in this example, it says t equals 2 seconds for the penny to reach the ground from 84 feet down to 0 in 2 seconds. This one is going to be negative 84 over 32, which is going to give me a negative value. I don't know exactly what, 42 over 16, 21 over 8, which doesn't really matter though because it's going to be negative. We're not going back in time. We want to know the positive sign. So it takes 2 seconds for the penny to reach the ground after Ramon has thrown it from 84 feet above the ground.